A fatigue crack doesn't announce itself. It starts at a stress riser, a fastener hole, a fillet radius, a machining mark, and it grows a little further with every flight cycle, hidden under paint or buried inside a forging. By the time it's long enough to spot with a flashlight and a mirror, it has already consumed most of the part's remaining life. That's the problem non-destructive testing exists to solve. NDT, also called NDI for non-destructive inspection, is any method that finds a flaw without cutting the part open or loading it until it breaks. The FAA lays out the accepted methods in Advisory Circular 43.13-1B and in the Airframe Handbook. 4 of them do most of the work on a shop floor. Each one is there because the other 3 would miss something. The cheapest tool in the kit is liquid penetrant, usually called dye penetrant. The part gets cleaned down to bare, non-porous material. A low-viscosity dye is flooded across it and wicks into anything open to the surface by capillary action. After a dwell period, the excess is wiped off the surface and a developer is dusted on, a fine white powder that acts like a blotter and draws the trapped dye back out. A crack far too fine to see with the naked eye becomes a red line visible across the hanger. The limitation is baked into the physics. Penetrant only finds flaws that break the surface. Seal that crack under paint or peen the surface closed and the dye has nowhere to go. It's also unusable on porous material because the entire surface would bleed. Swap the visible dye for a fluorescent one and you get fluorescent penetrant inspection, FPI, read under ultraviolet light in a darkened booth. It's the standard for engine rotating parts like fan discs, compressor discs and blades because it resolves indications a visible dye would lose. FPI is also where the industry learned one of its hardest lessons. In 1989, United Airlines Flight 232 lost the fan disc of its number 2 engine in cruise, lost all 3 hydraulic systems with it, and crash-landed at Sioux City. Investigators traced the disc failure to a fatigue crack that had grown from a metallurgical defect in the titanium. The inspection requirements that followed changed how much of the disc bore had to be covered by penetrant inspection. A method only works on the surface area it's actually applied to. Penetrant stops at the surface. Magnetic particle inspection reaches just past it, on ferromagnetic parts only, like steel landing gear components, engine mount bolts and shafts. A magnetic field is induced through the part. Where a crack interrupts that field, flux leaks out and forms 2 tiny poles right at the discontinuity. Iron particles, suspended in oil or carried dry, bridge that leak and draw a furry line along the defect. Orientation matters more than anything else here. A crack lying parallel to the field lines barely disturbs them, so the part gets magnetized twice, once circular and once longitudinal, to catch flaws running in both directions. When the inspection is finished, the part is demagnetized. A residual field on a steel component collects ferrous debris and can disturb a nearby compass or sensor. Eddy current works on anything that conducts, magnetic or not, which puts aluminium structure back in play. A coil carrying alternating current is held against the part. It induces circulating currents in the metal, and those currents generate their own opposing field that the coil can sense. A crack forces the eddy currents to detour around it, and that change in the coil's impedance shows up as a deflection on the instrument. 2 things make it valuable on the line. It needs almost no surface prep, and it reads through a thin layer of paint or primer. It also reaches below the surface. How deep depends on frequency. Lower frequencies go deeper, but you give up resolution to get there. That's why the bolt hole probe exists, a rotating eddy current probe dropped into an open fastener hole, mapping cracks radiating out of the bore where no eye could ever reach. Everything so far has been surface or near surface. Ultrasonic inspection goes all the way through. A transducer pressed against the part through a couplant gel sends a short burst of high-frequency sound into the metal, typically a few megahertz. The sound travels until it hits a boundary, then reflects. The instrument times the echoes. The back wall of the part returns one echo at a known depth. A void, an internal crack, or a delamination, where the plies of a composite have separated, all return an earlier echo, and where that echo lands on the screen tells you how deep the floor sits. Because the timing is that precise, the same probe measures remaining material thickness. That's how corrosion gets tracked on a skin panel from one side without removing it, and how bonded composite structure gets checked for disponds that leave no mark at all on the outside. Ultrasonic and eddy current meet on the same part. In 2018, a CFM56 fan blade separated in flight on a Southwest Airlines 737, and the NTSB traced the failure to a fatigue crack in the blade's dovetail. That's the wedge-shaped root that slots into the fan disc and locks the blade in against centrifugal load, the most heavily loaded part of the blade and the least visible. The FAA's emergency directive ordered a one-time ultrasonic inspection of every dovetail on the high-cycle engines. The follow-up airworthiness directive made it recurring, and it accepts either ultrasonic or eddy current at an interval later tightened to 1600 cycles. An airworthiness directive is a legally binding FAA order requiring a specific inspection or modification on a specific fleet by a specific deadline. It carries a compliance time, and flying past that time makes the aircraft unairworthy. Where the floor lives picks the tool. Every one of these methods is a calibrated procedure with a qualified operator behind it. NDT technicians work to formal certification levels, and the actual technique, the frequency, the dwell time, the acceptance criteria, lives in the manufacturer's maintenance manual for that specific part. Treat this as an explanation of why the methods exist. The AMM and a certification remain the authority on how to run them. What all four share is that they buy time. They find the crack while it's still a line on a screen and while the part is still sitting on a bench.